Alright, in this video we're going to talk about the relationship between the graph of fx and f inverse x. So, as you know that if you have y equals to fx, right? So x is the object, right? X is your object and y is the image, right? It's the object and this will be your image here. So, when you inverse of y, then you are getting x, right? So now means that y, if you inverse, the y will become the object and x will become your image here, right? So to say that actually the coordinate, for example, if you have xy coordinate here, so when you're mapping from x to fx, right? Fx, which is your y, under the mapping of f, so means that this will be your x coordinate, this will be your y coordinate here, right? So now when you're moving back from here, so this become your object, right? Your object. So means that when you inverse back, so the image here will become the object, which will be your x coordinate actually, and this will be your image, right? Your image. This is your object, this is your image y. So now if you inverse back, so this will become your object, right? The y will become your object and the x become your image. So easy to say that. So if you are the characteristic is, if you find the inverse, the coordinate also will be interchanged here. So become xy, the xy will be getting yx. Alright, so they are reflecting about the line y equals to x. Means that the point of xy and yx have to be same distance from the line y equals to x here. So this is happen only when you have inverse, right? The inverse of the function here, right? The inverse of the function here. So I to see that let's say you want to draw, this is the line, this is the graph for y equals to fx, right? So when you reflected about the line y equals to x, this is what happened. The coordinate here, they will be reflected when they are reflected about the line y equals to x. Bila mereka pantau pada garis y sama x, these two, the x and y coordinate will be changing, right? So means that the object will become the image here and the image will become the object here, right? So when they inverse back, so now means that this is -1, 3, right? The -1, -3 going to be, when they reflected about the line y equals to x, it will become -3, -1, right? -3, y is -3, -1. So this will be the coordinate for the after inverse. So the -2 here, this is 0, -2, right? The y-intercept. So you have -2, 0, become the x-intercept here, right? Become the x-intercept here. And for this point, the 2, -1 will happen to be -1, 2, right? -1, 2. So you have -1, 2 here, right? -1, 2 here. So they are reflected, and the distance from this point to this point is the same. The distance is the same. The distance is the same, and also for this distance is the same from. So now this will be your 3. The x-intercept will become your y-intercept, and for this point, which is 4, 1, right? 4, 1 will become 1, 4, right? 1, 4. So will become 1, 4 here. So if you sketch the graph, they will be exactly, they were reflected, right? They were reflected about the line. So they will go up to this point here. Can you see that? They are actually symmetrical about the line y equals to x. So this will be the graph for y equals to f inverse of x. This is to show the properties of the graph of inverse of x, inverse of f, and inverse and fx is symmetrical about the line y equals to x. So I hope you understand what is meant by this graphical representation of its inverse and its function.